Welcome to the massive open online course on Aspen Plus. In today's lecture, we are going to discuss about the processes with electrolytes. Electrolytes are the substances that produce electrically conducting solution when dissolved in water. Basically, they are some molecular species that dissociate partially or completely into ions in a liquid solvent, mostly in water, or some molecular species precipitate as salt. Okay. For instance, we can talk about NaCl, that is the common salt or the salt which we use for cooking. Okay. And if you put some NaCl in water or common salt in water, and if you stir it completely, it will get dissolved. So you will not find any trace of NaCl with your naked eye. You will see only water. So that is called dissolution. Now, what happens in the solvent water? NaCl dissociates into Na plus ion, that is sodium ion, and Cl minus or chloride ion. Okay, this Na plus and Cl minus, they remain in ionic state in the water solution. Okay, so this is the perfect electrolyte solution in solvent water. Okay, now NaCl is a strong electrolyte, so it completely dissolves or dissociates into water. There are some electrolytes which are weak electrolytes and they partially dissolve in water, but all of them are those molecular species. They get either dissolved partially or fully, and they can precipitate as salt also. For instance, if we have an excess of some ion, say chloride ion, and excess of some potassium ion into that solution, then after some time, when we find that the solubility limit of the potassium chloride or sodium chloride is reached, then any excess amount of those components will get precipitated to the bottom of the solution. Okay, you will find the solid particles of those salts. So that is also a property of electrolyte. Okay, they either dissociate or precipitate as salt. Another characteristics of electrolyte system is its speed of reaction. It is very, very rapid reaction. Okay, and due to that, the equilibrium is almost reached instantaneously, and chemical equilibrium is always assumed. Okay, here we find a few examples of electrolytes. First set is aqueous solution of acids and bases. Which are the acids? We will find hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, HF, HBr, these are also acids. Okay, and bases, alkaline solution, that means that is NaOH, KOH, that is sodium hydroxide, potassium hydroxide, they are bases, and aqueous solution of NaOH and KOH, they are also electrolyte. Then solutions of salts. NaCl, I have already talked about NaCl, sodium chloride. Similarly, sodium carbonate is also a salt which can produce electrolyte. Then calcium carbonate, sodium sulfate, potassium chloride, these are also salts which can produce electrolyte system. Then acid water solution, like solution of hydrogen sulfide, carbon dioxide, ammonia, hydrogen cyanide. The solutions of these components can also generate an electrolyte. And finally, water containing some amine solutions like monoethanol amine, diethanol amine, or methyl diethanol amine. So these are the examples of electrolyte system. Now we can talk about some solution chemistry of electrolyte system. as I have already said about the strong electrolyte or weak electrolyte, strong electrolyte means, say, NaCl, HCl, these are strong electrolyte because they completely dissociate into the solvent. But there are certain weak electrolytes also, they partially dissociate. For instance, if you have the phosphoric acid, that is a weak electrolyte, then acetic acid, this is also a weak electrolyte, they partially dissolve in water. Okay, and the ionic reactions among ionic species, that means suppose if you have sodium ion, chloride ion, then potassium ion, if you have carbonate ion, they react with each other. That means Na plus and CaO3 minus, they react with each other to form Na2CO3. Okay, sodium carbonate is produced. If we have excess of sodium ion and carbonate ion in the solution, after some time you will find some sodium carbonate salt will get precipitated at the bottom of the solution. So this ionic reaction among ionic species also is a property in an electrolyte system. And in that manner, they form complex ion also. And complex ion doesn't mean that they will be stable ion always. They may be unstable ions, but they are complex ions. And salt precipitation and dissolution, already I have talked about. So these are few important things about the solution chemistry of electrolyte system. Now you might remember, while selecting the components in Aspen Plus simulation window, we usually always select the whole component. For instance, we can select NaCl. Say it is NaCl. Then we know it is sodium chloride. Or we can say Na2CO3. Then we know this is sodium carbonate. These are well-known things. We can write HCl also. Right? So these are conventional component name. And the moment we write them, then Aspen Plus can understand which component we are talking about. But have we ever approached to define an ion? We have never. But Aspen has the option to identify the ions also. For instance, if we enter Na plus, then it will identify as a sodium ion, and which is conventional. That means Aspen can understand that we are looking for sodium ion only. So the sodium ion is the component name in this case. Similarly, we can write CO3 minus minus. So CO3 minus minus, the carbonate ion is well accepted by Aspen Plus. But if we have some complex ions, then Aspen Plus may not know such complex ions. Then we have to define the molecular structure and then we have to define it that way. But common ions are there in the database of Aspen Plus. You can just call them and put them over here in the component ID. Aspen Plus will understand what you mean by them. Okay. Similarly, Cl minus ion is also there. Another thing is that the chemistry, that is solution chemistry. In the solution chemistry, you can either specify the reactions or you can specify the reactive components. Okay. So among these components, available components, which are the components they are reactive? That you can say that NaCl is reactive, HCl is reactive, Na plus is reactive. For that matter, in this list of components, everything is reactive. So we can say all components are reactive. Okay. Then you do not have to specify anything else, that all components are reactive. Or you can specify some inert components. Like if you feel that for this example, Na2CO3 will not react. Okay. then you can say Na2CO3 is an inert component. So you can specify, then this component will not take part in any kind of reaction. Okay. Or in most of the cases, we have to specify the reactions. Specify the reaction means in the reaction stoichiometry, there are three types of reaction. One is equilibrium, the salt, and dissociation. Okay. Now, these are the types of reaction that we are talking about. First one is equilibrium reaction. Now, equilibrium reactions are due to the partial dissociation of weak electrolytes or ionic reactions between or among ionic and molecular species. So whenever such partial dissociation occurs, then equilibrium is reached very fast. So that is about equilibrium type reaction. And the opposite is dissociation reaction, where the complete dissociation of strong electrolyte happens. So when electrolyte is completely dissociated, say NaCl or KCl, they are strong electrolytes, so they completely dissociate. And when that kind of reaction happens, we have to say it's a dissociation reaction. And the opposite of dissociation is salt dissolution or precipitation of salt. So these are three kinds of reactions: equilibrium, salt, and dissociation. So whenever we have to define the reaction type, either we have to say equilibrium, salt, or dissociation. Now, if we choose dissociation, then we have to choose the dissociating electrolyte as well. So whether NaCl is dissociating or Na2CO3 is dissociating, that we have to fix. Now we can say both are dissociating. In that case, we have to select two reactions. In the first reaction, we will say NaCl is dissociating. In the second reaction, we will say Na2CO3 is dissociating. Then salt. We have to define the precipitating salt over there. And the third one is equilibrium reaction. In the equilibrium reaction, we have to choose the component, say Na plus and Cl minus. One ion of Na plus and one ion of Cl minus will produce one molecule of NaCl. So that is the equilibrium reaction stoichiometry that we have to choose. So here you can see the stoichiometry is Na plus Cl minus is equal to NaCl. Actually, it is a dissociation reaction because NaCl is completely dissociated to Na plus and Cl. It's not an equilibrium reaction. But for an example, I am showing how an equilibrium reaction looks like. So there will be a reversible sign over here. Okay, it's a reversible reaction. Like that, you can add the second reaction as well. Okay, and you have to identify the components and put them in the stoichiometry. Now, let us take an example problem and then let us try to solve it in Aspen Plus. That way we can understand it better. So this is the example problem that we are having. The example problem says, in the vinyl chloride production by hydrochlorination of acetylene, the reaction products contain vinyl chloride, 1,2-dichloroethane, hydrochloric acid, and acetylene. Okay, so these are the products. And HCl is washed in two absorbers. So obviously HCl will not come alone, and in absorber there will be a gas stream, so probably HCl will be carried through some acetylene or something else. Then HCl is washed in two absorbers. So the gas stream carrying HCl will enter into the first one where pure water, whose temperature, pressure and flow rate has been given, it is used as a solvent. So water is used as a solvent, where an aqueous solution of HCl is produced by absorbing the major part of HCl from the inlet gas. And the inlet gas also, the specification has been given that flow rate, and inlet gas is completely vapor with a pressure 1.5 bar. And here the components of inlet gas has been given. It is 5% HCl, 5% acetylene, 10% 1,2-dichloroethane, and rest vinyl chloride. So vinyl chloride is the major component. Obviously, the production is vinyl chloride, so vinyl chloride is the main thing. This scrubber operates at 50 degrees centigrade and 1 bar. Okay. And then we come to the second one. The second one, the aqueous solution whose flow rate, temperature, pressure has been given of NaOH. So it is a solution of NaOH in water. 0.2% NaOH is used to completely remove HCl from gas stream. So we have not only water, but in water we have given some NaOH so that the rest of the HCl which is there in the gas stream, that can be removed. The second scrubber also operates at 1 bar pressure with 0 heat due to it. So in the first case, we had scrubber operation at 50 degrees centigrade, 1 bar, and the second scrubber operates 1 bar with 0 heat duty. So this is an adiabatic in nature. Now we are supposed to model this process using Aspen Plus. So this is the complete problem. Okay. So basically what we now have to do is we have to have 2 scrubbers in series. In the first scrubber, we have a gas stream. In this gas stream, we have 5% HCl, and we have some acetylene, 5% acetylene, 10% 1,2-dichloroethane, and 80% vinyl chloride. Its temperature, pressure, and flow rate has been given. Water is poured from the top, okay, pure water, and some scrubbing occurs over here. The gas stream, which is also having some HCl, because all of HCl cannot be removed through water. Here water will come, in which majority of HCl will be carried forward, and lean gas will go and pass through the second absorber. Here we are having some solution of NaOH in water, and this liquid NaOH will produce Na plus and OH minus, okay, and we will carry HCl over there, so HCl will produce H plus and Cl minus. So Na plus and Cl minus will react and we will get NaCl dissolved, and H plus and OH minus will have H2O. So this is the salt solution we can expect through this liquid stream, and the gas stream will come out from the top, and we expect that this gas stream will be very, very lean with HCl. Almost no HCl should be there. So that is the job of a scrubber. Now electrolyte systems are so fast that a normal flash, at least for the calculation purpose, the flash 2 module of Aspen Plus can be used over here because reactions are very, very fast. Okay, we do not have to use any absorber model over here because it is not required. Anyway, first let us go to the Aspen Plus window and let us see what can be done.